The Holmdel Horn Antenna is a large microwave horn antenna that was used as a radio telescope during the 1960s at Bell Telephone Laboratories in Holmdel Township, Monmouth County, New Jersey, United States. It was designated a National Historic Landmark in 1988 because of its association with the research work of two radio astronomers, Arno Penzias and Robert Wilson. In 1965, while using this antenna, Penzias and Wilson discovered the microwave background radiation that permeates the universe. This was one of the most important discoveries in cosmology since Edwin Hubble demonstrated in the 1920s that the universe was expanding. It provided the evidence that confirmed George Gamow and Abbe Georges Lemaitre's Big Bang theory of the creation of the universe. This helped change the science of cosmology, the study of the history of the universe, from a field for unlimited theoretical speculation into a discipline of direct observation. In 1978, Penzias and Wilson received the Nobel Prize for Physics for the discovery. Description: the horn antenna at Bell Telephone Laboratories in Holmdel, New Jersey, was constructed in 1959 to support Project Echo, the National Aeronautics and Space Administration's passive communications satellites, which used large Earth-orbiting aluminized plastic balloons as reflectors to bounce radio signals from one point on the Earth to another. The antenna is 50 feet in length with a radiating aperture of 20 by 20 feet and is constructed of aluminum. The antenna's elevation wheel, which surrounds the midsection of the horn, is 30 feet in diameter and supports the weight of the structure by means of rollers mounted on a base frame. All axial thrust loads are taken by a large ball bearing at the narrow apex end of the horn. The horn continues through this bearing into the equipment building, a cab. The ability to locate receiver equipment at the horn apex, thus eliminating the noise contribution of a connecting line, is an important feature of the antenna. A radiometer for measuring the intensity of radiant energy is located in the cab. The triangular base frame of the antenna is made from structural steel. It rotates on wheels about of center pintle ball bearing on a turntable track 30 feet in diameter. The track consists of stress-relieved planed steel plates which are individually adjusted to produce a track which is flat to about 1/64 inch. The faces of the wheels are cone-shaped to minimize contact friction. A tangential force of 100 pounds is sufficient to start the antenna rotating on the turntable. The antenna beam can be directed to any part of the sky using the turntable for azimuth adjustments and the elevation wheel to change the elevation, angle or altitude above the horizon. With the exception of the steel base frame, which was made by a local steel company, the antenna was fabricated and assembled by the Holmdel laboratory shops under the direction of Mr. H. W. Anderson, who also collaborated on the design. Assistance in the design was also given by Messrs. R. Regan and S. A. Darby. Construction of the antenna was completed under the direction of A. B. Crawford from Freehold, Monmouth County, New Jersey, United States. When not in use, the turntable azimuth sprocket drive is disengaged, allowing the structure to weather vane and seek a position of minimum wind resistance. The antenna was designed to withstand winds of 100 miles per hour and the entire structure weighs 18 tons. A plastic clapboarded utility shed 10 by 20 feet, with 2 windows, a double door and a sheet metal roof, is located on the ground next to the antenna. This structure houses equipment and controls for the antenna and is included as a part of the designation as a National Historic Landmark. The antenna has not been used for several decades. Technical. This type of antenna is called a Holmdel reflector antenna, invented by Alfred C. Beck and Harold T. Fries in 1941. It was built by David C. Hogg. It consists of a flaring metal horn with a curved reflecting surface mounted in its mouth, at a 45 degrees angle to the long axis of the horn. The reflector is a segment of a parabolic reflector, so the antenna is really a parabolic antenna which is fed off-axis. A Hogg horn combines several characteristics useful for radio astronomy. It is extremely broadband, has calculable aperture efficiency, and the walls of the horn shield it from radiation coming from angles outside the main beam axis. The back and side lobes are therefore so minimal that scarcely any thermal energy is received from the ground. Consequently, it is an ideal radio telescope for accurate measurements of low levels of weak background radiation. The antenna has a gain of about 43.3 dBi and a beam width of about 1.5 degrees at 2.39 GHz, and an aperture efficiency of 76%.